We start with the limit as x goes to 1 minus of f of x, which means values of x that are slightly less than 1. And what we see is that those values produce on the graph y values that are slightly larger than 3 but close to 3. We observe that when we get even closer to 1 but staying less than 1, the function values are even closer to 3, which means the limit as x goes to 1 minus of f of x is 3. Now what we're going to do is look at the limit as x goes to 1 plus, and what we can see is values of x that are slightly larger than 1 produce y values that are slightly less than 3. And we conclude that the limit as x goes to 1 plus of f of x is 3. Now, since both one-sided limits are the same real number, we conclude that the two-sided limit, the limit as x goes to 1 of f of x, is 3. Now we look at x equals 2, and first we look at the limit as x goes to 2 minus, which is values of x a little less than 2. We see that the function values produced are a little bigger than 1, but very close to 1, so our limit is 1. When we go on the other side and look at the limit as x goes to 2 plus, we're getting values of f of x that are, again, close to 1, which means that limit is 1. And since these two one-sided limits are equal, the two-sided limit is 1. Now we look at 3. We look first at the limit as x goes to 3 minus, which is x values that are a little less than 3. They produce function values that are also a little less than 3, which means the limit as x goes to 3 minus if f of x is 3. When we look at the lim as x goes to 3 plus, however, we get something different. We can see that when x is a little bigger than 3, the function values produced are a little bigger than 1, which means that the limit as x goes to 3 plus if f of x is 1, both of these limits exist, but they're different, which means that the limit as x goes to 3 does not exist. And now last, we're going to look at the limit as x goes to 4 minus. We take x values that are a little less than 4, and what we discover is that the function values that are produced are big. Okay, in this particular case, it looks like they start at 5 and get as large as you would like. And when we get a little closer, we observe that the function values produced are even bigger. And what we conclude here is that as we approach x equals 4, from this side the function values get arbitrarily large. That limit doesn't exist, but we use the special symbol plus infinity to indicate that it doesn't exist because the function values get arbitrarily large. Now, when we're on the other side, x a little bigger than 4, what we can see is that the function values that pop out are close to 2, which means our limit is 2. And now, since these two symbols are different, the limit as x goes to 4 of f of x does not exist, and there's no special symbol we can use to indicate that. So remember here, this limit doesn't exist, but it doesn't exist in a special way, so we can use the symbol plus infinity. This limit doesn't exist, and there is no symbol that we can use other than does not exist to describe what's happening.